Now I'm going to zoom in a little bit on the first half of this just to make sure you can see very clearly what I'm doing. Now questions when we've got grouping symbols like this. Now the first set of grouping symbols is just to show this as the whole thing, so I'm not too worried about this part. But I am worried about the second part. Now questions when we've got addition, what we should do is distribute the addition sign. So if we have an add and a negative, that's actually going to give me, probably a good reason for me not to fill it in too quickly, is that's going to give me a negative. Positive and a negative is going to give me a negative, and a positive and a positive is going to give me a positive. Now what actually happens here is when we have the addition sign in front of the parentheses, this actually doesn't change anything. Negative 4x squared, negative 4x squared, negative x, positive 3, positive 3. So questions with an addition for the grouping is actually a fairly easy question to do. Now I have to group these terms together, so I'm going to look for like terms. So I can see a variable here. So I'm going to group those together. Notice I've also grouped the sign in front of the term as well. So this tells me what I'm going to do to these two terms. Because it looks like I'm actually adding here, but in reality I'm actually subtracting. So 5x squared take away 4x squared. So we know it's to do with x squared. 5 take away 4 is 1. Now when we come to the next one, I'm going to use a different shape for this one. I got negative 11x take away x. So it is important that you look at the sign in front, because it's not 11x take away x, it's negative 11x. So also, when there is no number in front, remember that means that it's just one of the variable. So what I've actually got here is negative 11 take away 1, which is negative 12, and then put the letter back at the end. For my last one, I can see that I have positive 8, and I have positive 3, so if I combine those, I'll end up with positive 11. Now, 1x squared I can also just write as x squared. So that would be my answer to that question. Also, a word of vocabulary we're going to use in a later chapter is, when we start with the highest power and then decrease the power, is we're going to say standard form. So we'll talk about that word now, and then hopefully when you see that in a later chapter, you can remember that vocabulary. Now for our second one, this one's more complicated because we've got to subtract here. So I'm going to start with this expression here to begin with, my n cubed plus n squared minus n plus 1. It says take away this, so I'm going to do that. But it's the rest of the terms where I've really got to be careful. If I'm going to subtract something that's negative, that's actually going to make it positive. The negative actually tells you do the opposite. So what's the opposite of subtraction? Then it's going to become addition. Same for this one, a negative of positive 1 is going to become negative 1, because the opposite of positive 1 is negative 1. Look for terms that are the same. So starting off with cubes first, I got 1n cubed minus 3n cubed. So 1 take away 3 is negative 2n cubed. Next term I got is n squared, so I got positive n squared. And I got another positive n squared, so positive 1 plus 1 gives me positive 2, so plus 2n squared. I also can see within here I got a negative n, and actually I don't have any other term that groups with that, so I'm just going to put down subtract n. And then when I get to the last term, I got positive 1 take away 1, and positive 1 take away 1 is 0. Now I could put add 0, but we also know from our work on properties that if you add 0 to something, it doesn't change anything because it's an identity. So I'm not going to put plus 0. Now if we continue with this one is a plus, so this is the easier one of the two questions. This is the one where I don't have to worry about anything. I can just copy down exactly like it says, negative 1. All I really did is just ignore the parentheses here. Because if you have a positive and a negative, it automatically makes a negative, so it's exactly the same. Now if we start to collect terms together here, oops, and I'm just going to erase my answer, so let me put that back. The highest power I can see is n cubed here, and this is the only term that has n cubed in, so I'm going to go with positive n cubed, or just n cubed. There's only one term that has n squared as well, and as it's a positive n squared, I'm going to put plus n squared. If it was negative n squared, I would see the negative sign in front, and I could put subtract. So I've done that as well. The only term involving n is negative 7n. And then at the end here, positive 3 take away 1, 3 take away 1 is 2. So I can put plus 2. Another advantage of circling your terms or underlining your terms is, so at the end of the question, if you have missed any terms, you'll see that they're not underlined. Because I've dealt with all my terms, I know that I've fully simplified. Now the last question has got two sets of subtractions in here, so we're going to have to be super careful on this question. In fact, I'm going to give myself a little bit more room for this one. So I got 3d squared minus 7. So I'm going to subtract the 4d like it says. But then I'm going to do the opposite of negative 7, which is positive 7. I'm going to subtract the d squared. And then I'm going to do the opposite of adding 4d. And I'm going to do the opposite of subtracting 7. Now I can start looking for those like terms. So I can see there's squares in this. So let's see how many squares. I got 3d squared minus, and I can put the 1 in if it helps me to remember this. So 3d squared minus 1d squared is 2d squared. Let's look at the next terms. I can see d's here. I got negative 4d, so remember to look at the sign in front. Take away 5d. So negative 4d take away 5d is negative 9d. And then for my last part here, I got positive 7 plus 7, which is 14. So this would be my answer for that question. Now I'm going to zoom back out a little bit now so we can see our questions on properties, and that might be a little too far. There we go. So for this section, we've got to choose from all the different properties that you can see up there. We've got a choice of 12. So this is one really where you've got to study ahead of time to make sure you know what's going on here. I'm going to label them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. For convenience, so I don't have to write out the whole phrase each time, but then you can see which is which. So the thing I notice about this one is the order is the same. It goes 5, 7, 3, 5, 7, 3. But the thing that moved is where the parentheses were. They were at the start here, but they moved to the end here. And I know that that one is the associative property. But notice this is adding here. So it's not section 1 because that says associative of multiplication. So it must be this one here, the associative property with addition. 4 add negative 4. Well, 4 and negative 4 are opposites. This is a positive 4 and this is a negative 4. So that tells me that one's going to be an inverse property. Let's see if we can find the inverse property up here. It says it's on addition, so here we go. The additive inverse property is number 10. 3/4 and 4/3. Now these are classed as the opposites as well. These are classed as opposites as well because the top and the bottom of the fraction are flipped over here. So these are also going to be, actually these are going to be inverses of each other. And as we're multiplying here, this would count as my multiplicative inverse. So this would be number 9. So questions where you times in by, the word is reciprocal when you flip the fractions over. And that would be one of your clues for that one. Or you could say, this one, the 4 is on the bottom, so this means divide by 4. But this one's on the top, which means times by 4. So there's your inverse. This one here is 3, this one's on the bottom, which means divide by 3. So that's another reason why that would be an inverse. And the dot, of course, means multiplication. So another reason why that one's 9. These two things are identical, x plus 5 and x plus 5. So that's just very simply your reflexive property. This is an easiest one to spot, I think, of many. This is the one where you're going to multiply out. So you do 5 times 7, 5 times 2. That's your distributive property, which is answer number 5. Part F, we got ABC, ABC, so it's the same order, so it's like this one up here, so it's the associative property again. The only thing that changed is what we grouped. Here we grouped A and B, here we grouped B and C, so it's associative on multiplication, which is number 1. G, also another fairly easy one. If you times by 0, you get 0. So that's the multiplicative property of 0, because you can see I multiplied by 0. So that would be answer 4. 8 times 1 equals 8. So I started with 8, and I finished with 8. That is our identity property. And you can see that we multiplied there, so this should be the multiplicative identity property, which is answer number 8. For part I started with 10 and I finished with 10, so nothing changed. So this is also an identity property, but this time it was on addition, so that would be answer number 11. Part J, 7, 3 and 1, but on the other side I got 3, 1 and 7. So it's the same numbers, but I'm adding them in a different order. When that happens, that's your commutative property, but as I was adding here, this is going to be option number 3. Similar with K, A, B, C, and then on the other side it's B, C, A, so they just changed the order, but they're still multiplying, so the change of order is your commutative property, which is number 2. And the way I remember L is, look how many parts of the question there are. 1, 2, 3. If you write 3 out, it begins with a T. And technically it's 3 things, so things also begins with a T. And so does transitive, it also begins with a T. So the last question is answer number 12. Hopefully not just because that was the last one that we actually did. Hopefully you appreciated what we actually were doing there. And it looks like all my answers have just moved, which is not going to be very helpful. So that one was 12. I had a few technical issues on that last one, but I managed to fix them. So this was the transitive property, which was number 12. Then we're going to start justifying the steps for each one. So we're going to look to see what happens. So I started with 5x plus 12, and then this negative 12 appeared. And actually on this side, negative 12 appeared as well. So when we do the same thing to both sides, we say that's the property of equality. And we just have to see what we did. This was subtraction, because you can see the negative here. So this is the subtraction property of equality, and I don't want to write out the whole thing. This one looks like a fairly easy one to figure out. Nothing changed on the right hand side, it's the left hand side that changed. 3 times x, 3 times 7. I multiplied out, so this would be your distributive property. This side here, I started with 5x, but then I got 1/5 times 5x. On the right hand side I got negative 20, but then I got 1/5 times negative 20. So I times both sides by the same thing, namely 1/5. So this would be the multiplicative property of equality, much like the other question here. I guess possibly you could have division property of equality if you read this part as dividing by 5, but I think as the question has a multiply in there, I think that's probably the best answer for this one. Now on this one here, we started with negative 4 and x, and then we've got x and negative 4. Now if you just think that it moved, you'd be tempted to put the commutative property. But what actually happened specifically here is the left and the right both switched over. The right came to the left came to the right, and when that happens, that's the symmetric property. So you've got to be very careful that you don't mix those two up, because that's fairly easy to do. If I scroll back and go and find my commutative properties, one thing you'll notice is there's only one equal sign on both of these questions. But if I go back to this question here, you can see that there are 2 equal signs, and that's another big difference between the commutative and the symmetric property. Now for our last question, we're going to write an expression for the perimeter. And the perimeter is when you add all these sides together. So we're just going to look for the like terms and add. So I got 6x, 8x, and 10x, which is going to be 24x. 23, positive 23, plus 2 is 25. Take away 25 is 0. So you could put 24x plus 0. We know if we add 0, that doesn't change anything with our identity property. So our answer should just be 24x. So make sure you take a good look through these questions. The test is going to look very similar to this, and then hopefully you can be successful when you come to do your first unit test.